Thanks.
Okay.
What did I say? Yeah, I was.
You should drop the slides.
No, we're all right. It's okay.
All right, yeah.
Okay, good afternoon, everybody. Thank you for joining us. Lovely to see all of you flooding in from the waiting room now. Thank you all for taking the time to be with us this afternoon at this webinar about the iWagon. For those of you who don't know me, I'm Maggie Simpson, Director General of the Rail Freight Group, and I'll invite our speakers introduce our speakers even in just a moment's time. In terms of this webinar today, we are recording it, so that means if you need to step away, answer the phone, collect a delivery, or do whatever else, you'll be able to listen back to it on YouTube when we post it up there, probably by the end of today or tomorrow, if at the latest. If you want to have a copy of today's presentation slides, we're going to be able to send those out to you. So please do drop myself or Yvonne at Rail Freight Group an email, and we'll get those slides out and over to you. And I'm sure Nigel and Sanjay will be sharing their contact details as well if you've got any further questions by the end of it. In terms of the way we're going to work today, we're going to have a presentation for around about 20 minutes there or so, and then we've got plenty of time for questions and discussions afterwards. So please do ask questions if you've got them. You have a Q&A box in front of you, so please drop your questions into the Q&A box. And if you can't see that, pop them into the chat as well. Either of those will work, and we'll try and take as many questions as we can towards the end of the webinar. Right, we seem to have stopped the flow of people coming in, which is good. Welcome to you all. So let's get on with it. It gives me great pleasure to introduce our two speakers for today. Nigel Day, who's the Business Improvement Director at VTG Rail UK, and Sanjay Albert, who's the Director of Engineering and Innovation at Knorr-Bremse. And they're going to take us through the presentation today about the iWagon, the collaboration that these two businesses have had in bringing this into the market, what's been happening so far, and what's going to happen next. So Nigel, Sanjay, thank you ever so much for your time today, and over to you.
Okay. Right, thanks everybody for coming. We've got a small presentation, as Maggie said, and we'll jump straight into it. Should we just jump onto the first slide? Yeah. So we just thought we'd start off with a little bit of history about where this product came from. It goes back 11 years now. We've been probably talking nearly every year for those 11 years. In 2012, we fitted a product called EP1001. And it was fitted to a JPA wagon, which was interestingly the same type of wagon that was in the petrol bridge incident. The EP1001 was a fairly simple system. It was a version of WSP, I think taken from EP2002, which is Knorr-Bremse's passenger product. The results of the trial were quite stark, actually, back in the day. And as you can see there, the wheel set on the left, after 2 years of running, was absolutely defect-free. And you can see the wheel sets on the right there was a real typical example of the fleet. And, you know, that's two pictures. But actually, when you look down the fleet, the whole fleet was of that ilk. It was one of the main reasons for that, though. It is a fleet that runs on
Nigel,
well, I guess rather.
Nigel, sorry, can I just stop you, because I'm getting some comments in the chat that they can't see any slides. Is it possible you could just drop your slides down, reshare? Would that be possible? Sorry.
Yeah.
It may just be that when we've transited from the practice mode into now, it's possible that we've lost them. Let's try doing that.
Okay, great. Back to this. Can everybody see?
Can somebody put in the chat whether you can see or not, please? Right, there we go. Yes, we can. Perfect. Sorry about that. Please carry on.
No,
Thank
yeah,
Okay, so yeah, I guess just taking that forward, you can now see the evidence of the trial back in 2012. So yeah, that was where we were back then. And if we just move on to the next slide, we struggled back then, I have to say, to realise WFP as a product. And although we saw the benefits in it, I'm not sure that the industry was quite ready for it. And maybe on its own, it had benefits, but business cases had to have paybacks, and we couldn't realise it. So we kept talking year on year, trying to understand how we could realise the product. And then we came, I guess, to where we were at the beginning of 2023 with understanding a couple of things, really. If we bolt on brake condition monitoring, it gives us a bit of a business case, because it means that we can eliminate some maintenance activities. What really helped the business case, I guess, now is connectivity and digital integration. So I think from this slide's point of view, it was still quite a challenge for our businesses to create what we called a tangible business case, a financially tangible business case, but we wanted to talk about where we want to be with our products. And sometimes I think if you put a better product to the market, you can grow more. So the other point, I think, really with this slide is a lot of the business case sits with our customer. A lot of the business case sits with the freight operator, and some of the business case sits with Network Rail. It's almost impossible today to bring all those people together and say, let's do this together. So what we did is we put that business case to our boards. We got the investment money, and then after the products entered the market, is we start to shape these things with our customers, with Network Rail, with freight operators. The other, obviously, main one in this was safety. So there are non-tangibles, reduced CO2, safety, other things. But what seems to be the case, as many of you are sitting here today, which is fabulous, what seems to be the case is that non-tangible business case seems to be doing what we need it to do, and really promoting the product. So moving on to the next one. So a little bit of just a picture here. We shared back in November. My boss Colin Denman shared this picture, and it was trying to say that really there's been little change in the freight wagon industry since back in the day. But what we just wanted to say now, if we just hit that, is yes, there's been a change. So really happy about that change. Really happy that we're sitting here today with a product that's working, because I'm not, you know, we weren't sure where we were, that absolutely this was going to be the future at this point. So a couple of things on safety, I guess. With regard to this product, the two major disasters that have also helped this product move forward, which one was Llangennych, August 2020. In the case of Llangennych, there's some discussion about a fault on the wagon, creating brake cylinder pressure. In the case of this product, it would keep dumping that brake cylinder pressure. It would keep controlling that slide, regardless of a distributor fault or a relay valve fault, until there is a limit where the product you can only run until you've got a certain level of air, but then it would send a digital signal to whoever needs it. It could be freight vehicle maintenance control, it could be Network Rail, national control, it can be the driver. So we're putting all of those digital integrations together, and in the case of Llangennych, it wouldn't have happened. In the case of Petrel Bridge, which is cited as railhead adhesion, it would have been much the same. The wagon would have been in control, and the WFP system would have been stopping the slide happening in the first place. Now, there is some discussions about the slide creating a flat in the wheel, and the wheel then can't climb out of that flat, so it just keeps sliding. In the case of WFP, that slide wouldn't occur in the first place. However, you know, maybe after many miles, eventually the system has to stop operating because of air consumption, and the alert would have gone to whoever the parties are and to the driver, and the train would have stopped accordingly. So both of these events wouldn't have happened with this product.
Okay.
Yeah, over to you.
Yeah. Thank you, Nigel. Good afternoon, everyone, and thank you for joining us on this webinar. So just to add to what Nigel just said, this is one of the classic examples of innovation, where we got an innovative product, but the business case quite doesn't stack up. And then, of course, we keep carrying on to make sure that somehow we make this work. And then with the change of events, especially with the digital stuff, which we will cover in a minute, which kind of gave a new lease of life to this product, because with the additional benefits came that additional business case, which then pushed this product from being a kind of on the edge to kind of over the edge. I think, again, thanks to our partners here, VTG, who kind of put up with us over a period of almost 10 to 11 years, working almost on a regular basis to find a possibility to get this over the line. So how does this iWagon and the concept of the WFP, the wheel flat prevention, work? The key thing here is the accident generators. This allows this product to be kind of wagon-based rather than a whole rake-based, which is a key differential. So you don't have to have the entire rake fitted with this for this to be effective. It can be a mixture of wagons within the rake because the power is generated within the wagon. The accident generators have two functions. As you can imagine, one is the power generation, and of course, we also use that to determine the speed of the wagon as well. The key here is the wheel flat prevention electronics, which is essentially a cut down version of the passenger WSP, the wheel slide protection. And the key reason why we want to differentiate the terminologies is just to make sure that they operate on a completely different basis when it comes to freight when compared to passengers. When we talk about passenger fleet, we know the air consumption, we know the availability of compressors on board, and we can go to the extent of making sure we meet the WSP criteria right up to the end. Whereas in the freight world, because the rakes have not been designed historically to that level of air consumption, we have to be careful on how we utilize air. So the control algorithms have been optimized for freight. But at the same time, we also need to know when to back off and say we would go so far as it's reasonably practical, but at the same time, we don't want to deplete the air on the wagons. And that was a huge challenge to make sure we get that balance right, because what we cannot have is the kind of being more conservative, but having wheel flats in the end, because we are giving up too early. And the balancing of it was the major criteria, which actually we solved in 2012. So just to be clear, so once we knew that the technology worked, then came the whole business case and how to make it commercially viable. And with the digital work that has come of fruition in the last, let's say, 3 to 4 years, that has brought it to the market. So the next big chunk is the brake condition monitoring. So this is the periphery elements of braking that we monitor with the system, because once we have power on the wagon, that gives us the extra ability to start monitoring the equipment. The key bit, like we have kept repeating from the start, is the digital comms and the connection of the wagon to the cloud. This was the major thing that we had to trial, the trial that we started in October last year, which we will come to in a minute. The digital comms has been quite successful in, let's say, lab trials. We've done that between the facilities of Knorr and VTG, and we were all quite happy with it. But of course, it's a completely different world when we put these kits into a freight wagon and let them run on their infrastructure. And then there were quite a few nervous few days between myself and Nigel waiting for the comms to work and then the wagons to communicate. So that was quite a celebration when we kind of knew that this technology is robust enough that we can have some secure communications from the field. Now, once we have that running, it's really a platform for further developments. Because as much as, of course, the safety behind the wheel flat prevention and the brake condition monitoring gives you the preliminary benefits that are kind of available on day one, it then opens up the discussions to what else does the operator actually need for his specific fleet, which can be implemented. And that's the key point, that it then opens up that platform for further developments. Okay. Anything you want to add, Nigel?
Not on this one, no. Okay, so just a little bit of a talk about the trials that we did. We fitted 9 wagons over 3 fleets. We fitted the tarmac flow Dunbar to Aberdeen first, and then soon after that, we fitted the Heidelberg flow from Clitheroe to Moss End, which is the part of the flow that was involved in Petrel Bridge. And then we did a Mendip rail flow, Whatley Merehead to Avonmouth. One of the reasons for the Mendip flow was the Avonmouth bank. And what we tried to do is find wagons that would give us the most activity and the most data with what we're doing. Now, just to say, and we'll come on to this in a little bit more detail, what we did here, and it was allow us to do a data comparison, it was quite important. We wanted to know what a normal wagon does in its day-to-day life, and we wanted to know what a wagon with WFP does in its day-to-day life. So what we did is we fitted all the kit on the 3 wagons and the 9 wagons across the 3 flows, but the 2 outer wagons, the actual WFP element of the kit is switched off. And that was a really, really good thing, because as you'll see on future slides, that gave us the ability to compare normal wagons with the WFP wagon. Okay, so those were the 9 wagons. We'll talk about the events in a little bit more detail, but there was a huge amount of events that happened in that period of time, and we'll come on to that. Do you want to?
Yeah.
Okay.
So like Nigel just mentioned, so we have the what we term as the active wagon, which is the wagon that actually corrects the wheel flat, the wheel slides, make sure that there are no locks, and it physically and actually intervenes whenever it sees any issues. The monitoring wagons, actually, as the name suggests, they just record what was happening. They don't intervene, but then they also give us the amount of damage that would have happened without the intervention. The intention was to have a monitoring wagon at the front of the rake, an active wagon somewhere in the middle, and then another monitoring wagon at the end of the rake. This was a kind of an assumption stroke aspiration, but as we all from the industry know, that's how the wagons started. The 3 of the 9 started their life with, and of course, after every run, every diagram and changes, of course, the wagons go all over the place, and of course, we can't control them. But the initial data were quite good, because we had them placed literally next to each other, and we were able to see exactly what happens through the various rakes. So if I quickly give you the numbers that you are seeing on the screen. from a monitoring wagon perspective, the key event that we measured was the number of axle locks. And here we were very clear to just make sure that we define our own criteria for them, just so that we are consistent. So this is an event where the wagon is in motion and on one axle is not rotating, or the speed is very close to zero. And the reason for that is very simple, because sometimes because of calculation errors, they may see a slight value, but clearly if it is nearer to zero, we consider that as a non-rotating axle. And as you can see, we had 37 really big axle lock events, and averaging to around 1 every 300 odd miles. And that was consistent across the monitoring wagons in the various parts of the rig. Now, on the active wagons, the good news is we measured the WFP criteria, i.e. how many times have the WFP been asked to come into action. And that is, again, defined by where the wagon speed is above 15 kph, and there is a difference between the rotational speeds of the axles, or between the axles and the estimated ground speed. So again, we are very clear. So it shows that there is some differential, either the wagon is about to slide or is sliding, or there is a kind of adhesion issue that's happening in that part of the route. And there we have actually found quite a number of events, and that is predominantly because of the time scale that we ran the trial. It started in October, and the data that you are seeing is between October and April this year. So that is predominantly the kind of the end of the leaf fall season. And we had 2 or 3 major storms, which contributed to much of the action that we have seen. And also, as we now get into the later half of, let's say, the leaf fall stroke, the winter season, we see a marked trend where we can see a big difference between a period A and a period B. So that's quite interesting. But again, these are early days. This is just one season that we are monitoring in this trial. But just to be clear here, the whole purpose of this trial was to make sure that the digital aspects of these wagons are kind of validated, and also the fact that these wagons are able to communicate and we can actively monitor them in operation. So that's the summary of where we are. And I think this is quite an interesting thing that we noticed. We've also presented this in the RFG, RWA, RSSB Innovation Conference in November last year. For those of you who attended it would remember the same set of slides that was presented. So this was in October last year, quite early on, since we released the wagons into operation. So the wagons literally were exactly like I said, the monitoring wagon in front, the active in the middle, and then the other monitoring behind. And it's quite interesting to see that the whole rake sliding, and you can see the monitoring wagons literally go down to 0 speed, whereas the active wagon in the middle corrects itself, and then the WSP kicks in, the algorithms kick in and make sure that the wheels don't just break off from the rest of the wagons. So it's quite an interesting graph, which shows the active wagon is doing its job, whereas the monitoring wagon, where it's not intervening, is just allowed to go by what would have happened naturally. Next slide.
Okay. I think just the final thing to add on that data, you know, I've been, I guess, running wagons now for too long, but probably 21 years. I had no realization how slippy the railway was. And even on the first day when that data started to come in, we were blown away, really, I think. And the 6.5 miles per WFP activity, whether that's a tiny piece of activity or something more significant, is significant in itself. 6.5 miles per control required to stop wheel damage. So just coming on a little bit, just taking you around the wheel again for those who haven't seen it. Wheel flap prevention we've talked a lot about. If the wagon, and it can only protect for so long, depends on how much air we add to the wagon. So, you know, you add 250 litre reservoir, gives you more. If you add 500, it gives you even more. So when it gets to a point where the air gets, where the system has to shut down because it's got no more air, it will create an axle lock detection. It's an emergency alert. That emergency alert can go into the cloud in a fast way. We've worked out how to get it fast down to where we need to get it to. Everybody will know that that train's in trouble. Brake condition monitoring we've talked about. It really is, I mean, we measure, most organisations do a brake test once a year. It's an analog brake test machine, and now what we're doing is constantly measuring the device, constantly measuring the brake system, and I think that would be quite powerful as more data comes in from that. Future-proof with multi-door sensors. The eye maintenance piece which we can present in future meetings, we are developing other digital technology. The perspective of VTG, I think, really is that we want digital information to allow us to drive maintenance events. I'll come on to that a little bit on the next slide. Handbrake status will come into train preparation, which is something we're working on, and I'll talk about that. It's an enhanced track-friendly wagon. We're no longer running wheels around the network with damage. We will be campaigning with Network Rail to try and help us develop this project with regard to some incentive. Obviously the telematics, harmonic frequency maintenance. Well, we've already noted that the generators, so if we won't see a wheel flat because we've got WFP, but if something happens, you do see in the frequency of what we call the mag in the generator, you do see frequency anomalies. And I think as time goes on and we understand faults against frequencies, that harmonics piece will become really good. And of course, there's a safety improvement in that as well. Just a little bit of the data challenge, and this is a big challenge for us. To allow this to be really a powerful product, we need to integrate the data, and also we need to understand and control the cost of that data transmission. So that has been a challenge for us. Just take you through quickly. IBM Maximo is asset management product that we launch, go live July the 8th. When all of this data comes together, Predge is a data analytics machine learning platform. All of our data, whether it's line side data, wheel check scotcher, whether it's digital wheel measuring, whether it's iWagon brake data, will go into Predge. Predge will tell us every morning whether a wagon's in trouble. That information goes to IBM Maximo, which goes to our fleet department. We've struggled a little bit with TOPS. TOPS is rather challenging, being an old system, but we've managed to data scrape out of TOPS. We've got a little bit more work to do there with the train preparation, because we need that data straight. We need that consistent information. Absolutely, as it comes into TOPS, we need it down on the iPads to work. To allow all this data to be controlled, we have a data lake. Now on the dashboards, there's three or four main dashboards. We have our internal joint dashboard, VTG and Knorr-Bremse, looking at the brakes, looking at the WFP activity, and I'll just show you a little bit of that. The safety in the train prep app is in development, but there's a lot of challenges with regard to making sure that all the different FOCs, with all their different rules, with all their different technology, that we're integrating with that appropriately. And then at the bottom, we're launching a system called Trago, and we're developing that, and we'll write more of this stuff onto Trago to understand what and to present that to our customers. So our customers also see exactly what we see from the point of view of forward planning, from the point of view of the digital program for maintenance, what their requirements are for shunting, etc., etc. So there's a little bit of a show of the data challenge there. So just a couple of glimpses into the softwares that we've developed. At the top is Traeger, as I've just said, and that's being developed further. The bottom is the WFP Knorr-Bremse's activity dashboard. The really interesting bit, you can see the 3 flows here. This was the heat map on the bottom right here. It was the heat map from the 3 trials, and you can see the Mendip trial down the bottom, and you can see the Dunbar and Venice and the Clitheroe heat maps fairly combined there in the middle of that. But you can zoom in on that and you can actually see every single WFP activity and exactly where it happened. So that, I think, is powerful data in its own right. We can trend that, we can see where the slippy parts of the railway are. We can really use that to inform us. And on the right, in development, is the train preparation app. Now, we have a lot of integration with freight operators, as I've said, but the point, here's a very, very top level quick point. If you can draw consist data down from tops, if you know which iWagons are fitted to your train, let's say all of the wagons were iWagon, and you knew your rear wagon was wagon 1, 2, 3, 4, you can check, you've got train continuity down the train, you can check all your handbrakes are released digitally, and you can check all your brakes are working appropriately. So you're into automatic train preparation, which is coming. And just a little bit, what now, where are we? You know, this is real for us. Trials are finished. Production is underway. There are teams of people in Melksham, in Munich, in VTG, driving this hard. We do have multiple customers signed, both for new build and retrofit, and we are trying to keep up with where the product's going. App development underway, data integration with TOPS, as I've just said, and the freight operator companies are key to the next few months of our life to get that app really working well. So that's where we are, and I think I think that's it. So thank you very much, everybody.
Thank you.
Nigel, Sanjay, thank you. That was fabulous. Can you drop your slides for me, and then we can see you a little bit larger whilst we take a few questions? Hit the big, yeah, brilliant. Thank you. Right, people listening in, I'm sure you've got more questions than we've got in the chat for the moment, so please do let us do that. But just, I'm just going to take Chair's prerogative on a couple just before we start. Nigel, you talked about the sort of, on your picture with the wheel, of some of the things that that it's possible to do once you've fitted the data connectivity and the power. It's kind of what's the limit to that? Because, you know, I certainly know people who are interested in things. You talked about handbrakes being left on, but also, you know, sand spillage out of hopper wagons, uneven loading, things like that. Is this a platform that can expand into more areas in future?
Yes, absolutely. I have to say, and our sales director is pushing us hard, because so load sensors, for example, in the side bearers of wagons, which will go into a new algorithm in maybe phase 2, will allow the wagon to digitally give you the load of the wagon, the exact load of the wagon, whether it's unbalanced, whether it's overloaded, and how it is. Door sensors is definitely a requirement from some of our customers. So I think where we're going with the product is we're finding different customers will have different requirements. We're increasing the capability with regard to the sensors, and we're going to create an options list, a little bit like, you know, sunroof of your car. And we'll be working on that probably over the next year to 2 years. And a lot of that will come at new builds. So it'll be quite good for us, because new builds take a little while and we can develop in parallel. So yes, absolutely. The options list will come out probably after we've got through the first fit in November.
Of course. Okay, question coming in. Has it, from Neil Syme, has any analysis been done of what, if any, impact WFP has on the braking capability of the train?
Right. Yes, because we have the Whisper that we use, which is the WSP evaluation rig. just to make sure that we are in line with the requirements. But just to be clear to Neil, these are all purely internally kind of agreed requirements, because there is no real standard to test against. And that is something we are also in discussions with RSSB. But from a pure braking perspective, just to be clear, the WFP is like an add-on system. We only use it for braking during the service braking, and during emergency, we switch the system off. But there is no reason why it cannot be left on. But we are just working with the standards team to make sure we get that level of maturity before we can leave it in all the time.
Brilliant, thank you. Question from Adam Bevan. Does the system add any additional weight to the wagon or unsprung mass of the wheel set?
No, not enough to worry about.
Yeah,
right.
Absolutely not. Yeah. I mean, we're talking a few kilos. It's nothing significant.
Cool, brilliant. Question from me then. I think you talked a little bit about this being something that reduces wear and tear both on the wheel and on the track. Just thinking about the wheels, do you have any sort of sense of what that would mean in terms of maintenance interval?
Yes. I think probably to say, and most people who run wagons will know this, even though it's not always called damage, flats, cavities, pitting, small damages, whatever it might be. In England, predominantly, you could probably roughly say that 30% of your wheel sets are changed for those kind of activities. In Europe, it's a little bit less, I think at 22%. We believe it's not just the wheel set alone. I think, just to give you a flavour, Maggie, if you're digitally measuring your wheel set and you're predicting, because you've overlaid your mileage with that, you're predicting when that wagon's wheels are going to run out. And bearing in mind the wheels are normally the critical element of the change. What you can do is you can harmonise all your other activities around it and change some of the other activities to happen without having to pull the wagon out of traffic. So we're looking at, in some cases, you're doing a PPM every 6 months, you're doing a VIBT every 12 months. In my humble opinion, there's not a lot of logic to that. It's just because we've always done it that way. Now what you're doing is potentially pushing your activities with traffic inspections, with other things, with bolstering up the bits you need to bolster up. We're pushing those activities out to maybe 140,000 miles. And if many customers are doing somewhere around 60, the majority of customers, I know intermodal is much higher, then you could be pushing out some of your periodicities up to 2 years.
Wow, brilliant. A couple more coming in. Chris Wells, what reserve is there in the wagon auxiliary reservoir if braking from 75 miles an hour and the WFP is active throughout the stop?
Hi, Chris.
Hello, Chris. Yeah.
Let's do some maths there. How quickly can you do it?
Yes, we've done the work, and that was one of the longest pieces of thing that we had to do, Chris. So we have assumed the brake stops for those particular values you just quoted, because they are the standard ones for the calculation. And we believe with 250 liters of additional supplementary reservoir that we have connected to the system, we would be able to get rid of most of the wheel flats with a cutoff, which we have put in to make sure that we have one service braking left in the supplementary reservoir, so we don't actually get down to the 0 bar. And exactly the trials have proven that even with this kind of restrictions, we have seen no real damage to the WFP wagon, which is another proof to show that this calculation actually works in real life, also in service. So we've done it both ways. We've done it theoretically, and now with the digital overlay, with the data that we have received since October to April, we have also proved it in the field.
But if I could, I guess, just add, I think we were talking about it a little bit this morning. At the moment, we're running with the extra 250 litres, but that's all based about for how long you want to protect the wagon for. And I guess, Chris, we could have an offline technical discussion. It might be with some wagon types at new build, we fit two 250-litre reservoirs. It might be that, for example, with low deck intermodal, where you haven't got as much space, you might fit 125. So we're going to be mapping that in detail across all the different wagon types to maximise its protection, but also, you know, with the limitations of the wagon design, because you can only have so many reservoirs on a wagon.
Cool. Okay, question from Steve Rhymes. Is it the intention to fit these sensors as standard on all new VTG wagons?
Yeah, so absolutely. iWagon is our standard product. We already ordered new build iWagon. We have already said to every single builder out there, and we're working hard with them, and Knorr-Bremse is working hard with them out in Europe. Everything we import into this country, everything we build will be iWagon. There's no doubt about that. And we're going to retrofit as many wagons as we can over the coming years. So yes, it's our standard product. Yes, it will be.
Lovely, thank you. A question from Roger Glaw. What certifications will the system have, and which ATEX approval will the system carry?
Good question.
Very good question. It does not have the ATEX approval as of today. But again, Roger, thanks for bringing it up. That's one of the key things that we are being pushed for. Now that people have realized the benefit of this, that's the next market, and both VTG and Knorr are working on that. With regards to the other certifications, we follow the general WSP requirements from the passenger fleet. So we do the same levels that we have adopted in the passenger side. Also on the freight side, when it comes to software being SIL2 to all the SIL3 electronics, the EMC bits, the 50121s. So all that remains exactly the same. On top of that, we also do the WSP evaluation rig, the Whisper testing. And then we follow the CSMRA regulations in the UK to put the vehicles into operation. And that's the route that we have followed for the trial with VTG as the owner to place the assets into operation, along with, of course, the freight operating companies and Network Rail.
Yeah. It's been big. You know, we've had, as I say, we've had teams in Munich looking at all the WISP stuff, looking at all the air consumption stuff. We've got teams in Melksham working on it, and we've got a peer review team in VTG with software experts, with, you know, even cybersecurity has to be thought about. I was probably not going to raise it, but, you know, as new build, with the new build situation, we are procuring iWagon with all our new builds. New builds in TSI land tend to be, well, you've either got a box, you tick it. If you haven't got a box, you can't tick it. We're going to have to campaign together with a technical file with robust evidence that we can create that box to tick, to allow new builds to come in fully fitted with iWagon, and we'll be, as soon as we're a little bit further down the road, because we're working hard to make sure we've got all our certification in place by November. As soon as that's happened, we're probably going to be knocking on the door of RSSB and OR and DFT to say, well, look, this is our product, this is our technical file. Please help us fit this at new build.
Brilliant. Okay, and then a question in from Adam. How frequently is the data fed back to the cloud?
That is a complicated topic, Adam. We've spent days and days in a room with the towel wrapped around our head, balancing out data transmission and the cost of data transmission. Because what the cost of the product is really, really important to us, because we couldn't blow it out of the water. It still has to be a cost viable product. I'm sorry if I'm not going to give you a straight answer, but it's quite complicated. For example, we can have standard streaming of data from the brakes. We can have that daily, we can have that weekly, we can have that monthly. It depends on how we want it. What we've done is we've set up a whole infrastructure. So, for example, if there's a major shock, because we've also got shock sensors in the kit, we haven't talked about it a lot. Then it will start capturing data. It will go back 6 minutes and it will capture data for 1 second for a period of time. So incident data, we've got this enhanced data capture situation, and then standard data such as just WFP activity, the data transfers when it happens. Then on top of that, we're going to have the train prep data. So it is a challenge. Happy to go into a bit more detail, but we could probably, like I said, we spent many days in a room and we could probably bore the life out of you on that topic. But it is structured in that way.
So essentially what you're saying is that if it's safety critical data, you'll know about it quickly. And if it's maintenance data or other kind of data, you can take a more nuanced view on how often that's harnessed in effect.
Absolutely, Maggie. And the safety critical data, the data capture is much more intense. So it's like every second. So we're capturing a huge amount more data when it's safety critical incident stuff. Yeah.
And then a follow-up from Roger Glaw. Are there any concerns in the industry if the cargo is hazmat about installing a system on the wagon that does not have ATEX certification? I mean, presumably those two things come hand in hand, don't they? You won't do it till you have.
ATEX certification, absolutely. We're working hard on that. We want to be fitting dangerous. One of our customers is already dangerous goods wagon. We are challenged now to get the ATEX certification as quickly as possible. There's just a whole bunch of different levels of ATEX certification. We need to make sure we're capturing the right level of ATEX certification.
Cool, you're on the case. All right, look, both of you, thank you. That was hugely informative, really interesting, and every time I hear from the both of you, you've made more progress than the last time. So it's brilliant to get an up-to-date summary of it. And thank you to all of you online for your questions and for joining us today. We won't give you a virtual round of applause, but we'll give you a virtual round of applause. There you go. Just a few notices then from me before we finish. A reminder, this will go up on YouTube. If you want to get a copy of the slides, please just come through to Yvonne or myself, and we will get those over to you as quickly as we can. We are, for some of you on the call, we might be fortunate enough to see you next week up at the Multimodal Trade Show up at the NEC. We'll be there all week at that show, Tuesday through Thursday on the RFG Pavilion. And if you haven't booked your table already for our awards dinner on the 5th of September, those tables are booking now. And finally, reaching right out into the future, we've just confirmed our November group meeting will be up in Middlesbrough at the AB Dawson facility. That's on the 13th of November. Whether we'll have more to say about iWagon by then remains to be seen. Quite probably you'll be able to at least give us an update. But finally, thank you all again. And Nigel and Sanjay, thank you so much for your thoughtful presentation and indeed for all the work that you've done and continue to do on this product. Thanks all. Enjoy the rest of your day.
Thank you, Maggie.
Thank you, Maggie. Thank you.